Hey ladies and gents, what's up? It's Papa Bale and welcome to the channel. Alright, so I got two circuits here. One is being powered by this power supply, and the other one's being powered by these two batteries in series to give us 24 volts. And then this one's done by a reed switch, and that one's done by a trigger coil. So you see the reed switch over there blinking, and it's firing this coil. And when I hit the switch, the other circuit will turn on. But let's get this one up to speed. Alright, having it angled like that is, I guess it's not working as well. But we'll turn it all the way up and see what happens. There we go. Alright, so the reed switch is getting up to speed. I mean, yeah, wow, that's 24 volts, nothing special. Oh, we got, I think. Alright, this is nothing though. I mean, we got a whole nother motor basically we're going to be checking out here. And the reed switch had fallen a little bit out of place. There we go. That's more like it. And there's our amp draw. 0.5 at 25 volts. That's awesome. Alright, here we go. Second gear. Here it is. And then the amp draw on this one goes down. The amp draw altogether goes down because of the speed. That's awesome. We're gonna blow up some batteries with that. That spike. Oh man, I should get some readings on that. I'll set up the oscilloscope for another. Well, I might pause it and do that right now. Heck yeah, we're gonna set up the oscilloscope so we can get a reading. See if we're getting any spikes. Be right back. Alright, so we're gonna turn the power back on. We got the oscilloscope hooked up. Oh yeah, we're getting spike. Very spiky. That's good. Less wavy, more spiky. I like it. And this is off of the reed switch coil coil being fired by the reed switch. I'm going to do some adjustments in just a second here. There we go. Look at that. That's pretty sweet. It's a negative dip for sure. Very strong on the negative side. Or south side. Alright, let's hit the second button here. Oh, we got a positive hit there. We're losing our spike though. We're losing spike. Oh wow. Yeah, we got positive hits now. So we gotta, I don't know how to modulate that. Turn off the additional power, or the second. But that's gonna stay on, and we're gonna use this from this coil, and then hopefully this coil will be generating something similar to this. I don't know though, because it's not using a reed switch, it's using a trigger coil, and then readings will be different. I'm almost guaranteeing that. So I'm going to hook it up to the other coil now, and we'll see what kind of readings we're going to get from that one. And of course it's got its wave that's kind of hidden in the whole thing, and it's kind of spiky too. Alright, be right back. Alright, so we got this coil's 30 gauge strand hook up to the oscilloscope, and this is what we got before turning it on. Now let's turn on that circuit and see what happens. Very more spiky. That's awesome. Granted, it's only about 25 volts. I think that's because it's a trigger coil. (29.6, 31.2) peak to peak. So that's very small. So I thought it would be small. Damn. Huh. I'm wondering if we put the core in there. Be right back. Alright, the cores don't exactly fit. Alright, I have to like stop everything. But as of right now, they won't fit in there. They're really, really close though. So. So I don't know. I think we're good to start charging. Although I think the coil setup with the reed switch has a much better spike. Like, it's a much more pronounced spike. So that leaves me with a dilemma. Can I make this thing run on 2 reed switches? I'm pretty sure I can do it, but it's not going to be easy like everything else has been easy. But I think if I run it through the transistor like I did this reed switch, we can get equivalent speed. So that should be pretty fun. I mean, this rips, man. This is parallel 24 volts. And it's literally only like a total of, well, you got your man watts, which is the wattage of both of these added together. And then you got the other wattage, which is the maximum wattage that's being applied across the board parallel, which is going to be 24 volts parallel. But, you know, for the amount of, there's 24, and the wattage, actually, we got it like, this was, when you got both of them on, it's 25 volts and 0.1 amps when they're both on. So I'm figuring it's going to be right about the same for both of these systems. It's drawing about 100 milliamps on these batteries in series. And then and same with this, when they're both on, of course. When this one's running on its own, it's like a lot more. It's like 7.5 watts instead of 2.5. And I mean, seriously, to get this thing going, yeah, that reed switch is not in a good place. There we go. So that's that many. That's 4.3. We're going to move it till we're drawing right here. Roughly. We start drawing 1. But, you know, as it increases in speed, we can now adjust it. See, now we're doing 1 at 9.5. And that'll go away as well. Or are we steady now at 9.5? Nope, there we go. Okay. $12. We're going to go back down to 0.1 maybe. And that's our kinetic view. That's the kinetic energy. And that's our wave coming off of our secondary coil, which is over here. That's the one that's hooked up right now. And we're getting a wave pattern because it's only inducting. So it's only getting energy from the magnet passing it. That's what's showing up here on the meter. Look at that. I backed that switch out a little bit. So we're pulling 0.7. We didn't lose any speed from me doing that, I don't think. And we probably saved the switch. But this is with both magnets hitting the switch all the time. Like it keeps the range and it keeps bouncing out. So it'll get to this point where only one magnet is hitting it, and it's kind of, you know, not fun. It's weak. All right, well, that's that. Here, let's drop this amp, draw it down a little bit. That is so cool. That's a lot of voltage though, man. That's 24 parallel. That's awesome. All right, I'm gonna cut it. I don't like, but you know, the faster it goes, the less energy it uses, because the amp draw goes down and the voltage stays the same. So that is more efficient for it to go faster like that. Way more. Like, it's bar none the way to go, faster. But without like changing anything really. All right, thank you very much. Peace out. Have a good night. Please subscribe. Bye.